Hey everybody, welcome back. Today we're going to be doing the first of our set of lessons for chapter 17, which is all about the interaction of light with reflective materials. So we're basically talking about reflection and mirrors. We'll talk about straight mirrors in this first part, and then the second half of the chapter we get into curved mirrors. And so this is one of the things that's called geometric optics is the name of this kind of thing between this unit and next unit, which gets into lenses, which is a whole different kind of thing. So a couple of things to know about this unit. There's going to be a total of 4 videos. There's one video on this introduction section here, and then I broke down chapter 17.2, the curved mirror section, into 3 different parts. And so kind of keep in mind that there's a total of 4. That will keep the videos individually a little bit shorter. Second thing to keep in mind, for this particular chapter, you need to have some drawing tools available to you. So regular notebook paper is generally fine, but you need a straight edge, something with a little bit of strength to it. It doesn't have to be a ruler specifically. We're not going to do measurements that way, although measurements are certainly helpful. But even something like I've got a stack of Post-it notes, anything with a good straight edge to it that's fairly firm so you can draw a nice solid straight line. You can use an ID card a lot of times. Sometimes they're not long enough depending on the size of your picture. And then the other thing that you need to have, pencils are good, but you need to try to find a protractor. That's the half moon shaped thing that we use to calculate or to measure angles. So you need to find one of those, either print one off from the internet. I'll post one up on Google Classroom, trace one off of a computer screen, something usually for what we're doing here online, we can do about 5-degree intervals. Don't try to worry about doing every single line, but try to find something. Or you may have one lying around the house, so you can pick one up sometimes at like Rayleigh's or the dollar store. Dollar store is a great place to get that stuff. Just makes your life a lot easier to have those tools for both chapter 17, the mirrors unit, and then chapter 18, the lenses unit, because we're going to be doing a lot of technical drawing. That's actually one of the major skills. We don't do quite as much math here, but I am going to have you kind of pay attention to some careful scientific drawing, in a sense, using paper models as a way of analyzing certain types of problems. So it's a particular skill that I want you to work on. I'm going to be testing you on that, or your performance assessment will be on constructing one of these models. So there are lots of ways that you can do these online as well. So if you've got a good graphing program, there's ways that you can construct these drawings online. So anyway, just get you going. All right, so this one, introduction, basically reflection in mirrors, kind of what's going on. So you can see a picture like this. This is not Lake Tahoe, but man, it sure looks like it. And you can see there obviously is reflection going on. So as a reminder of what's happening, that you've got light coming from an illuminated object like the sun somewhere, is bouncing off of that mountain there in the distance. Those rays are reflected back from that mountain, are scattering every direction. So when you look at the mountain itself, some of those are those reflected rays coming back directly to your eyes, assuming that you're actually at the lake and not looking at the computer screen of the lake. And then there's another set of rays here that's doing something interesting, which is the set of rays that's bouncing back from the mountain to the surface of the water, and then bouncing off of that surface of the water and back to you. So they're getting to you indirectly. That's that reflection piece. Most light rays are getting to you indirectly, but these are even more indirectly than usual. And you can tell that there's a difference in the image form between the picture on the left and the picture on the right. Obviously, the picture on the left, beautiful, clear, still water. Image on the right, nice little gentle breeze, something like that's causing ripples on the surface of the water. So we see 2 different types of reflected images. And this is to get you thinking about different types of reflection, that reflection's happening all the time. Reflection doesn't just mean that there's a beautiful image being formed. In fact, seeing the mountain itself straight on is an example of reflected light rays bouncing back from the mountain to your eyes. So again, just sort of getting you to broaden your image of what reflection is. And then in this chapter, we're going to play a lot more with that real fancy type of reflection that gets you a nice clear image. So with this one, what we're talking about, some vocab words here. There's actually 2 different sort of general categories of reflection. One of them is called specular, that's that word on the left, and the other one's called diffuse, which is the word on the right. And they're related directly to the image surface itself. Certain types of surfaces are very flat and can allow the rays of light to bounce back in a coordinated, regular pattern, kind of like in that specular reflection picture on the left. Other rays that are surfaces that are more rough, when the rays hit those surfaces, they bounce back, but they don't all bounce back at the same angle. They bounce back all over the place. They're scattered. So this is the difference between these 2 types of reflection. Specular reflection is what you would kind of consider to be like a reflection. Like when you look in a mirror, or when you look in that calm, flat lake. That's what specular reflection actually means. Actually get to my pen tool, right? But that's what a specular reflection actually is. true, organized, arranged type of reflection where you see an image. Diffuse reflection is more like everyday kind of reflection. Like when you're looking down at a piece of paper on your desk and you see it reflecting back white light to you, that's diffuse reflection. Light is bouncing off of that surface and getting back to you, but it's not forming a particular image. So the couple of other words that I want to make sure we kind of get clear in here is these three words over here: ray model, incident ray, reflected ray. When we are talking about light in this particular chapter, remember in the last chapter we talked about three basic kind of models that we use to communicate light behavior. There's the ray model, the wave model, and then there's the particulate model. In this particular chapter, we're going to use the ray model, where we're going to use straight line arrows to represent rays of light. And it's sort of representing the general direction the light is traveling. So we're really simplifying that sine wave pattern into a single straight line. Because it's a ray, this is a geometry thing, rays always have to have arrows to it. Think of them as being like vectors. They're always going in the direction that the arrowhead is. Notice how all of the rays that are drawn in these diagrams have arrowheads to it. It's a key part of drawing. And again, we're doing technical drawing in this chapter, so be aware of that. You can't just draw like that. You actually have to draw an arrowhead on there. You can draw fancy arrowheads if you like. You can draw, kind of like interesting arrowheads. I don't really care, but you have to draw some sort of an arrowhead to it. That's part of the ray model. Second thing is these terms incident and reflected. So reflected rays are kind of obvious. Those are the ones that are bounced off of the surface. In the pictures that I've got on the screen, the reflected rays are all drawn in red. The term incident is more new to students. Incident is kind of like saying incoming. It's the rays that are coming from the illuminated, from the luminous object towards the surface that they're doing. So all of the incident rays here are colored in blue. We don't really care about the color coding. That's not really important for us long term, but those words incident ray and reflected ray get used a lot. We will use incident angles and reflected angles as well. So incident means incoming. It's the one that's coming towards the surface, and the reflected ray is the outgoing ray after it's hit the surface. So going along with this, if we're going to try to draw patterns, draw ray diagrams, and be able to use drawings as models to represent what's happening when light hits surfaces, we have to be able to kind of carefully construct these sorts of drawings. So the first thing here is we have a real easy kind of rule called the law of reflection. And the law of reflection is really nice. The law of reflection means that whenever a ray comes in and strikes a surface, it's going to bounce off at exactly the same angle, kind of going the opposite direction, but I'll show you what I mean by that. So here's how we draw this, and I'll kind of give you the short version what the law of reflection is. Let's say our object is this little circly dude over here, and we've got an incident ray coming from this dude towards this thing. This right here, I'm going to use the abbreviation ML, which stands for mirror line. So we'll say this is my mirror. And let's say that there's a light ray coming from this object to the mirror line. When the light hits this mirror, it's going to bounce back. And it's going to bounce back at exactly the same angle. So here's how we draw this. Number one, when we draw this, you can kind of see I have this little dashed line on here. The dashed line here is the normal line. Now, you may remember this from earlier in the year. The normal line is perpendicular to a surface, and this is also called a normal line right here. It's an imaginary line. It is perpendicular to the mirror line. So again, this is the normal line right here. And whenever we draw angles, or when we talk about angles, we always talk about the angle between the ray and the normal line, not between the ray and the surface. This is really important. This is something that students get wrong. Notice where I am drawing this. It is between the ray and the normal line, not over here. This is because, for example, if this was the surface and the ray was hitting here, then it's still this angle right here between perpendicular to the surface, not this angle right here, which would be an awkward kind of imaginary line. So again, it's always between, when we're drawing these sorts of things, the angle that we're talking about, when we talk about the angle of a light ray, it is always directly between, again, the incident ray, or the ray, and the normal line. So this, how we abbreviate this, just like in math class, we're going to use the Greek letter theta, which is kind of like a skinny O with a belt across the middle, to indicate our angles. And because this is the incident ray, we're going to use the abbreviation theta I. So again, this is it, theta with a lowercase I next to it. This means incident angle. So when our ray bounces back off of this, it's going to back off or bounce off in such a way, and I'm drawing it, so pardon me, but if I was doing this for real, I would need to have a protractor and try to get real close on this. I would try to make sure that this angle, the reflected angle, was equal to the incident angle. So the two angles to the normal line should be equal and opposite. This is called the law of reflection, that the angle of incidence equals the angle of reflection, like that. So that is the law of reflection. The incoming angle and the outgoing angle are equal to one another, symmetrical around the normal line to the surface. So angle of incidence equals angle of reflection. So those are terms right there that we've got. This works even in multi-mirror systems. So like you can imagine right here, I have mirror number 1, and then I have mirror number 2. This is what you see when you go into like dressing rooms, or if you go into those like mirror houses where you've got, all these different mirrors that are at angles to one another, you get all these sort of chaotic bouncing sorts of things. So in this case, if we were to try to draw this, here is my first angle of incidence. So this is number 1, and it would bounce back off at, I'm going to try to do it as close as I can, something like that. So these two would be the same. And then once it hits this mirror, it's going to bounce a second time. So I would construct a second normal line perpendicular to the new mirror, and my new bounced off ray would be quite a bit wider, something along those lines. So again, these are rays. I better make sure I got those on there. So this would be angle of incidence number 2, and this would equal angle of reflection number 2, and they continue to bounce as they hit all of these different mirrors. So again, this is called the law of reflection. Angle of incidence equals angle of reflection. So we can use this now to actually be able to picture where images are in mirrors. Now, if you've ever held a flat mirror, you know there's an image of you in that mirror. It's not you, it's an image of you. Little kids get really confused by this all the time, right? They want to know, if you ever see videos of like toddlers, they want to know where the other little kid is that they want to go play with. Kittens and things like that, they will see an image in a mirror and just all freak out because I'm wondering where the other cat is, right? So how do we actually use this idea of angle of incidence, angle of reflection to figure out where an image is, or where it appears to be is a better word, in a plane mirror? By the way, this is how you write the word plane, plane meaning flat. A lot of times students think I'm saying this, like a plane mirror that way. Well, a plane mirror is a plain mirror. A plane mirror is a plane mirror. So here's how we draw these things. This is called a ray diagram. This is one of the assessments that I'm going to ask you to be able to do, is to be able to draw a ray diagram for a plane mirror and to show me where the image would be. So when doing this, we need to use a couple of different rays. We're always going to use 2 to 3 different rays to locate where our image is. So let me kind of do this with example number 1. Here's example number 2, which you could practice if you want to. We will be practicing this at meet number 1. By the way, when we get together on Monday or Wednesday, or Monday or Tuesday, whenever our meet is. So here is image number 1. Here's our little object right here. And I want to know where this image is going to be. So here's how we draw this. Number 1, we would draw a ray coming straight at the mirror. So this is ray number 1. This is the one that we are doing. Now, ray number 1 is going to do different things. It's going to bounce back this direction, but it's going to appear like it's going directly into the mirror. You guys know that when you point at a mirror, it looks like the thing is inside the mirror someplace. So what we are going to do is, this is the reflected ray over here, but there is a virtual ray that continues, if I could draw it in a straight line, straight back. Notice how I'm drawing this with a dashed line. All of our virtual rays, which are behind the mirror, are drawn in dashed lines, and it's sort of an interesting thing. So this is sort of continuing this kind of ray through here. So this is where it's going to look like it's going. Okay, ray number 2. This is a real ray. It's an actual like ray of light. Imagine this is a laser beam incoming here and then reflected here. So we've got our 2 angle of incidence and angle of reflection. So there's our angle of incidence right there. So with this now, what's different is that our reflected ray is going to be the one that we're going to use to create our virtual ray behind the mirror. So this is something you just have to kind of memorize how this works. But it is the virtual reflected ray. So it's in line, it's the same direction as this one, but in the opposite, behind the mirror. So it's going to kind of go like this. So that's ray number 2. So again, incoming ray number 1 goes straight into the mirror. The reflected ray goes straight out. And then the virtual reflected ray continues in the opposite direction from the reflected ray. For ray number 2, it comes in and then bounces. Angle of incidence equals angle of reflection. And then our virtual ray is the opposite direction from the real reflected ray. So these ones over here are real rays. In other words, they actually exist. It's actually beams of light bouncing around. This is the apparent rays that are behind there. And what you'll see is that where these 2 rays cross right here is the location of our image. So if our original object was just a dot, that means our virtual object, the object in the mirror, would be at that particular spot. And what you should see is it should be kind of literally a mirror image, right? It should be just as far into the mirror as you were outside of the mirror. So if this was, 5 meters away from the mirror here, this image looks like it's 5 meters inside the mirror. So again, this is how you draw these sorts of things. Again, it's the reflected rays that you are extending behind the mirror. So again, it's a little bit of a weird process to sort of draw these. I'm going to skip this one for right now to make sure that we can kind of move on through our video, not get this one too long. So again, if you want to practice drawing one, that's what you do. Again, the reflected rays kind of bounce back this direction. This is the incoming. Here's your reflected ray. Your reflected ray is your virtual ray behind there. So in the real world, you'd be doing this with a ruler and a protractor to make sure that your angles are equal and that your lines are nice and straight. And if you do this correctly, this is part of what your ray diagram conventions are. So by the way, the term convention is the rules that I was using. Real rays are done with straight lines, solid lines. Virtual rays are done with dashed lines. The other convention is that rays always have arrowheads to it. This is sort of the rules of drawing. We call those conventions. And we've talked about the real versus virtual rays. Okay, so here's what this looks like with practice. I'm going to do this heart one, and I'm going to do it relatively quickly here because this is the one that we'll practice doing some of these during the meet so that you have an opportunity to practice constructing these, not just with dots, but with actual objects. So I'm going to pick 2 different spots on my heart. There we go. Try to make them different. Like this one, I maybe pick this one and this one. Actually, with this triangle, I'd probably pick all 3 of them, but I'll show you how to construct this. So ray number 1 goes straight in. Again, in the real world, if I'm doing this on homework, I'm doing this with a ruler and not just, on a virtual item like that. So that's the incoming ray. It hits that and bounces back. So the reflected ray actually goes straight back this way. So this is our reflected ray. This is our incident ray. I know it looks weird to say that. And then our reflected ray is going to continue straight back this way. So this is our virtual ray. That's the reflected ray. Then for the second ray, the second spot that's up here, pick any spot here you want to. It doesn't really matter where it is. Close by, further down, doesn't make any difference. Pick some spot. There will be a ray of light that will go basically from this image straight to that spot. Again, please, you use a ruler. I don't have a ruler that I can use very well here. And then you're going to have your reflected ray. Ooh, that's bad. I don't like that one. Your reflected ray. Again, you're going to construct your kind of imaginary little normal line. Your reflected ray should be equal to your incoming ray, your incident ray, right? So you're going to try to make those 2 equal. And then your reflected ray is extended into the virtual zone here. And it's going to be, again, in a straight line there. So this is equivalent to that dot right there. That's where that image is going to form. Then you're going to do the same thing with a second spot. So I'll do this with I'll do it in a different color so you can see it. The green one, again, it's going to come straight in. It's going to hit here. It's going to bounce back that direction. And then the reflected ray is going to bounce back this way. Notice I'm just sort of drawing it off into the distance. Then I'm going to pick a different spot for my other bounced ray. It doesn't really matter where it is. I can kind of pick this spot right here. Don't have to pick the same spot. In fact, it's usually better for your drawing if you pick 2 different spots. And it's going to bounce back again at a relatively steep angle, something along those lines. Again, if I'm doing this as homework, I am constructing that little normal line to make sure that my 2 angles are equal. And then this one is going to bounce back over there. And that is that spot. So again, notice how I use 2 different spots in the mirror. You do not need to use the same spot. In fact, it'll make your drawings a lot easier. 2 different spots. They should not all cross at the same spot since they represent 2 different parts of the heart. And if I'm drawing my heart, you're going to kind of map it out. This spot is the close-in part of the heart like that. And this spot was the bottom of the peak down at the bottom. So it would kind of look like that without my crazy distortion to it. So you can kind of map out a series of points to do a ray diagram. Again, we're going to practice this more. I just want to introduce this idea to you so that you can see it. I realized that I missed couple of ray heads there. I want to make sure that that's on there. So again, mapping out these different spots using angle of incidence equals angle of reflection, using 2 rays for every meaningful point on the object. But that's how you're going to focus, form images when you do this. Okay, last thing I want to mention is some sign conventions that we're going to talk about when we do these sorts of things. DIDO, HIHO. The distance of the image, height of the image, and the orientation of the image. Now, you've used mirrors before, so you know what this is. Typically, we use these sorts of abbreviations to represent this. So DI would be the distance to the image. DO would be the distance to the original object. It kind of makes sense when you do this sort of thing. So DO and DI should be equal to one another. So DI equals DO. In other words, the image looks like it's as far back in the mirror as the object was in front of the mirror. HI and HO, if we've done these two things right, if it's a regular flat plane mirror, these two should also be the same. That the height of the image should be the same thing as the height of the object. That's why if you want to see your full body in a mirror, you have to get really far away, right? In order to make make your virtual, your virtual size really small compared to the mirror, and then that image looks like it's really far away on the other side. And then the orientation of these is always upright. It's reversed left to right, but it's upright. We're going to see more things with the images being flipped over when we get into the curved mirror section. So I'm just sort of introducing these concepts right now in terms of DIDO, HIHO, and orientation of the image. These are upright images. You know when you look at a mirror, it's upright. You know that it's inverted left to right, but it's upright in terms. So it's upright, but maybe it's reversed is the correct way to do it. It's not upright and inverted top to bottom. It's reversed left to right. And that has to do with angles of incidence and angles of reflection. So there you go. Introduction to plane mirrors and drawing plane mirror diagrams. So we kind of went through a variety of vocab today. So specular and diffuse reflection. All of these things when we're doing this is assuming specular reflection and drawing these ray diagrams, real rays and virtual rays. Rays always have to have angles and arrowheads on them. That the angle of incidence equals the angle of reflection, and that when you are drawing virtual rays, they match the direction of the reflected angle, not the incident angle. There you go. So there you have it. Introduction to plane mirrors. I'll see you at meet number 1, and we'll practice drawing some of these. Hope you enjoyed it. See you guys at the next video. Dun, dun, dun.